For today's review, we're talking about solving equations and inequalities. So we've been solving equations pretty much all semester. We're not going to be spending a ton of time on solving the equations. We are going to go through one problem together. We're going to spend most of this time focusing on the inequalities. And so let's take a look at the first couple problems here. So solving equations. So this actually relates to number 7 on your worksheet. So it's asking us to solve for x. So by the end of our equation, or by the end of our problem solving, we want to end up with one single number for x. All right, so in order to do that, we want to start by 1, combine the like terms. So when I see like terms, again, I'm looking for any term that is the same. So my 2x and my negative 7x both have an x with it, and so I can actually combine those two. Now I want to remember on my 7x here, I need to include the negative sign. So the sign to the left of a number always goes with that number in particular. So my negative 7x, I have a positive 2, so the sign to the left. And here, when I don't see a sign, it's actually telling me that it's positive. So if I don't see the sign, it's positive. But the sign is always to the left of the number, so we can't forget that this is a negative 7x. All right, so combine the like terms. So I'm gonna rewrite what I have on the next line. So 2x minus 7x is gonna give me a negative 5x plus 2 equals negative 13. All right, and so now I want to get this 2 over with the negative 13 in order to combine those like terms. So the second part is to subtract 2 from both sides. All right, and so I'm going to subtract 2 on this side, and if I subtract 2 on this side, I have to subtract 2 on the other side. So you think of this as a wall, the equal sign as a wall. So whatever I do on this side, I have to do on that side. So I have to put a negative 2 on that side as well. All right, so I'm going to rewrite this again. So my positive 2 and negative 2, those go away. That leaves me with just a negative 5x on the left, and on the right side, I combine my negative 13 and negative 2, so I add these two together to get a negative 15. All right, so now we have an equation that most of us probably recognize at this point. So just a one-step equation to where I can, if I want to get x by itself, I then divide both sides by negative 5. So third step is to actually divide negative 5 on both sides. So this negative 5, anytime I have a number divided by itself, is going to give me a 1. So my x, my 1x is left over on the left side. And negative 15 divided by negative 5, so negative divided by negative is going to give me a positive. And so x equals 3 is my answer. All right, so now on the second one, solve and graph the inequality. So if we remember our inequality signs. So greater than or equal to, less than or equal to, we have greater than and less than. So we have all these different signs. So greater than or equal to, less than or equal to, greater than, or less than. So in this case, we have a greater than or equal to sign. So we're solving this exactly the same way that we're solving an equation. When we come to finally graph the inequality, this sign is going to tell us exactly how to graph it. All right, so I want to start by subtracting 4 on both sides. So I'm going to rewrite this down here. So 2x plus 4 minus 4 is greater than or equal to 24 minus 4. So I want to get the x all by itself, so I have to get everything without an x onto one side. So I'll rewrite this. My positive and my negative 4 go away, leaving with 2x is greater than or equal to 24 minus 4, which is 20. Now my next step here, divide both sides by 2, giving me, when these go away, 2 divided by 2 gives me a 1. So 1x is greater than or equal to 20 divided by 2, which is 10. So our next step here is to actually graph it. So we have a number line. I have my 0 here. So anything going to the right, I'm going in the positive direction. And when I'm going to the left, I'm going in the negative direction. So I start at 0, at 10, so I'm just going to do this by 5s. So 5, 10. Now when I have the equal sign, so greater than or equals to, means that when I graph it, it's going to have a closed circle. So closed circle, so like this, means that we're including that number. So it includes the number. So I'd have a circle like that on my graph, a closed-in circle, filled in, meaning that x can be bigger than 10, or it could actually equal 10 as well. So that's why we have the closed-in circle. So if we think about all these other numbers going this way, all these numbers are going to be bigger than 10. So all the numbers, all the possible numbers are going to be bigger than 10. And so that's why we shaded in going this way. Because all of our possible numbers, which x equals, or which x represents, I should say, is going to be equal to or greater than 10. So if I was to take this 10 and plug it back into my initial equation, or my initial inequality, then the number that I get on the left side would either be greater than or equal to the number that I get on the right side. So if we take a look at that, this is a way that we can check to make sure our answer is correct. So I have 2, so anytime I see an x, I'm going to plug in the 10. So when I'm checking my answer, I have to plug in that 10 for the x. And so that's where I'm plugging it in. And so 2 times 10 plus 4 is going to be greater than or equal to 24. So 2 times 10 gives me 20 plus 4. It's going to be greater than or equal to 24. So we can see that 24 is greater than or equal to 24. And since this number on the left does in fact equal this number on the right, then I know this solution is correct. So if I plugged in any of these numbers to the right of 10, I would have a number that's going to be either greater than or equal to 24. All right, so let's take a look at one more of these inequalities. All right, so this one, again, we see the distributing. So meaning that whatever's on the inside of the parentheses is going to be multiplied by whatever's on the outside of the parentheses. So I've got negative 3x plus 15 is going to be greater than or equal to 0. So I start by distributing, and now I have a simple inequality that we can solve pretty quickly. So our next step is to actually subtract both sides by 15. So do a negative 15 on both sides in order to start getting the x by itself. So 0 minus 15. So these two are going to go away. So positive 15 and a negative 15 gives me a 0. So leaving me with just the negative 3x is greater than or equal to negative 15. So now I have a simple one-step equation that we've seen a bunch of times, but one thing I need to look out for here is that I'm actually going to be dividing by a negative. And so whenever I divide by a negative when I have an inequality, that means that I'm going to have to turn this sign around. So whenever I multiply, so multiply or divide by a negative, I have to flip the sign. Okay, so if we're multiplying or dividing by a negative, I have to turn the sign around. I have to flip it in the other direction. So my negative 3 divided by negative 3, that's going to reduce to 1, so that gives me a 1x. And remember, since I'm dividing by the negative, I have to turn the sign around. So negative 15 divided by negative 3 gives me a positive 5. So this is our answer. So all of my x's are going to be less than or equal to 5. So when I come over here to graph it, I've got 0 here, 1, 2, 3, 4, 5. So 5 here, and all my other numbers. And if x is less than or equal to 5, so again I have that filled in circle, and all of my numbers that are less than 5. So I'd be doing all these numbers.